So my name is Justin Buck, and I'm presenting an information management framework for environmental digital twins. I'm going to be showing a summary of the work of two projects that's been running for the last 18 months, with effective partnership between National Tropical Centre, CEH in the UK, British Geological Survey in the UK, STFC and British Antarctic Survey. And there's many co-authored this work listed on this slide too. So when we show digital twins presentations, we tend to start with a couple of definitions. So fundamentally, what we're looking at is that when we describe a digital twin here, we're looking at a tool to improve decisions and decision making. It's a virtual representation of a physical asset enabled through data and simulators for real-time prediction, optimization, monitoring, controlling, and improved decision making. That's our key output for any of this work. And the information management framework is relevant when we're looking at multiple digital twins and how we actually enable interoperability and services to be shared between those twins, and also potentially data and information to flow between different twins. And there are key elements to that. First is establishing that shared vision. Second is developing a conceptual framework. Agreeing and implementing digital commons. Digital commons actually gives us that interoperability. Delivering demonstrators. We need to show the value in this work and show it working to our stakeholders. And delivering components, so actual elements of digital twins. And this figure on the right-hand side actually shows all of those elements on one schematic. And the key thing is that when we develop as demonstrators, we do it in an agile way. So we're going to be developing effectively a thin slice vertically through these horizontal bars. We develop a piece of each in order to deliver value for users at each case, each point. The first project which we worked on in this actually developed a roadmap for environmental digital twins. I'm actually going to call it IMFe for short. And this project actually combined previous work in the UK by the Centre Digital Built Britain, where they actually defined a roadmap. They also defined elements that need to include a roadmap, include the foundation data model, reference data library, integration architecture, governance, and some other criteria in there too. And then we took this framework by CDBB. We combined it with the environmental landscape. And we also included 3 use cases to actually test the theory against in order to develop a roadmap that would make sense to users. And there were Antarctic digital twins by British Antarctic Survey. There's Land Insight, which is soil moisture and carbon, and also 3DT by the Met Office, which was atmospheric dispersion used for pollution events. So it's actually working across the environmental domain. These were combined into draft the information management framework. And we produced the model and the roadmap, which is available in this QR code. Second project, which started last October, was actually a pilot project. So on the pilot project, we've effectively got a structure where in the center, where we're actually doing a new iteration of the development framework. We're using the Hague-FRAS pilot study, which I'll cover in the next slide. And we're effectively going to be combining what comes out of Hague-FRAS with the work by British Antarctic Survey and others to generalize those components and produce a generalizable information management framework. We've got stakeholder engagement from senior stakeholders through to users and potentially communities of practice. And our main output is going to be a revised framework, which is on the key, and these are recommendations from the report I showed in the previous slide. Actual services, so one of the key services we'll be generating this asset register, which will enable digital twin components to be described and exposed and made discoverable, and the Hague-FRAS digital twin. The Hague-FRAS digital twin, it's a high impact case study. It's about biodiversity, and Hague-FRAS is a region just off the southwest of the UK. It's a cold water reef, and it's a marine protected area. So as part of the policy and the monitoring the region, we actually need to monitor it regularly. We need to report on the biodiversity, we need to report on its environmental health. And a lot of the surveys are done using marine imagery from autonomous vehicles. And you can see examples in the bottom corner. And the digital twin effectively it's building services images, so artificial learning, machine learning and artificial intelligence can be built on top. And that will enable decision making in terms of where to do surveys and also inform policy and reporting to stakeholders. So that's the work we're doing. We're engaging with the international community. So a key part of that engagement is digital twin of the ocean. under UN Decade, and we're a part of the Turtle Action, which is looking at interoperability between digital twins. And the second key one is we're a part of the new Turing Research Innovation Cluster, which is being launched this month at a parallel event in London, whilst the IOD meeting is on. And they're working across different thematic areas. They've got an area for environment, infrastructure, and health. J.Siddorn, who's one of the PIs on, is the PI on the projects I've just presented, is one of the leads of the environment sector. And these need to be multidisciplinary, sharing tools and techniques well aligned with the IMFe work, and need to address important societal challenges, and they need to be built using demonstrators and use cases to demonstrate the actual impact. So it goes beyond theoretical ideas through to actual impact and services for users. Just say thank you. We've had two grants from NERC, but a broad collaboration to actually achieve all this work beyond the initial co-authors.